Hello everyone, our team is from Xidian University in China, and I'm glad to present our algorithm SMILE in single object tracking task of VisDrone 2020. Today, 6 parts will be present to you. Notice that the most important parts are the third and the fourth chapter. The motion part provides very useful messages for the strategy part to make policy decisions. At first, let me give you a short description of single object tracking and the withdrawn challenging dataset. Single object tracking, or SOT for short, is a free modal task to track a single object which is given its bound box in the first frame and marks the bound box for this target in the rest of the frames. In VisDrone 2020 challenge dataset, there are 60 sequences in final submission, different from the challenge in 2018. There are lots of long time and night sequences, which makes the dataset more challenging. Here, the table shows us the sequence length in day and night. There are much more long time sequences at night. Besides, there are 29 sequences who has long-time partial occlusion and full occlusion. Of course, I guess these two kind of sequences affects the final score a lot. We conclude the most difficult problems which make this tracker lost target. One is camera motion or rotation. You can see from the first line, the camera rotated fast just in some frames. The ship has a large motion in less than 1 second. This motion will make target out of the searching area of the tracker. Then loss occurred. Under the second line, the motion causes an image blur. This will also cause bad influence on tracking. The other difficult problem is the caution plus similar object. When the caution happened, another similar object will be recognized as target. Then it continues to tracking this fault object, and most of the time it never comes back. The rectangle in red represents the MP tracker, and the blue represents SAM RPM++. The similar object is not only the object in same class, but similar appearance object in different class. So you can find it in this picture. The DMP track a wrong white object, but it is not a person. Generally speaking, the low light condition always make everything more similar, especially at night. This is our program framework used in this tracking game. We make everything in module and split them into 3 parts: prediction, tracking, and fixing. The data frame us into the first 2 blocks and then make policy decision in the fixing block. With the help of this structure, we could modify our strategy conveniently and concentrate on designing the new strategies. We have 3 kinds of motion models to provide the motion information, and now I will give you the detailed description. We try some of the optical flow method and finally use the VNC method. Because as you can see in the pictures, the left one has a better performance. This method is listed in the end of the PowerPoint. The second model is Kalman filtering. This method is famous in the industrial world. This method could predict a position for linear motion by using its history position information. When a collision happened, we could use this method to predict a possible position for tracker. So after a long period of time, we could retrieve it when the target was appeared again. This is our tracking strategies. We have 3 prediction models and 2 tracking models, and we use these 4 kind of strategies to make policy decision of tracking. In order to be concise, we use the first letter to represent the different models and use different color of boxes to represent the different type of models. Here is the main workflow of our method. We use 2 kinds of trackers which they can collaborate with each other. The DMP method has a robust score, but its bound box is not very steady. This steadily unsteady may cause target loss because just like the butterfly effect, the same mask has a steady result but not robust in similar object, and it is hard to judge target lost by its tracking score. After trying a lot of different combinations, we found a good way to use them. Here is the process of flow of DDT strategy. We use some mask to refine the bounding box from DMP. We can get a series of bounding box from some mask and then calculate the LU with the original DMP bounding box. Finally, after sort and selection, we got a new result from some mask, or we got the original DMP bounding box when this condition is false. The second strategy is tolerance searching strategy. This strategy aims to handle the situation of full caution or target lost. We define a search range by a factor relating to the time. TR is tolerance range from 0 to 1. When the target is tracked, it will go to the upper branch to track object normally. When the target is lost, it means this condition is false. We will increase the TR by this formulation. If TR is less than 1, we can stand still to wait target occurred again in a range of RT. If TR more than 1, we consider it lost too much time. So we can't stand still and execute MR strategy to find it back. Here are the tracking results. The red circle represents the search region, and the green box represents the tracking result. You can find that here is another person in middle picture, which is very similar to the original target. And in the DMP response map, we could find it will track a wrong person in next frame. But by using our range limitation, that person out of the range of searches, out of our search range. So we can make the box that stay still. Then we find him back when he came out from the tree. In this video, you can see a search range is very big because it experienced a long time full caution. The searching range will grow with time because the object is moving with time. In the last picture, the object came out from the trees and we found it back. These are three kinds of data strategy to find out the missing object. The first one is Kalman prediction, and the second one is history average position center, and the third one is image center. If the change of the optical flow is large, the Kalman prediction reset model will be disabled. If the variance of history center is large, the history mean position reset model will be disabled. If the reset model above are disabled, we use the image center reset model. In order to fill back the results when the target is lost, when the sense is nearly static or uniform moving, we could fill it by the first formulation. But most of the time, the sense is moving, so we must calculate the optical flow into the formulation as shown on the right. We select some summation, which you can see the improvement in implementing these strategies. And finally, we got the score of 22.335. Finally, we designed a new tracking framework combine motion and strategy together. In this graph, our methods are constructed step by step, and each step is used to solve a kind of problem in VisDrone 2020 dataset. This method is still not perfect for handling drones or UAVs tracking problem, but we could improve it in the future. And the code is still reconstructing and will be available as soon as possible. Here are the references used in this code. And this is our team information. Thank you for listening.